Okay, this is a toughie. We've got y equals x to the x power, and this is going to be a little bit of a challenging one to work with. We've got to be able to get the x out of the exponent. So when you have a variable raised to that same variable power, we have to solve this out just a little bit differently. And so what I'm going to do is I'm going to reach into my bag of tricks, and with y equals x to the x power, I'm just going to take the natural log of both sides. And this is a legitimate move because whatever I do to one side, I do to the other. And as long as I do the same thing on both sides, then I'm okay algebraically. And what does that give me? That gives me the natural log of y equals the natural log of x to the x. And this is okay. We don't have a problem with this. And in fact, this is really great because now I can take this x and get him out of the exponent. And so what I'm really going to be working with is the natural log of y equals x natural log of x. Now remember, the whole goal here is to find dy dx. That's our whole goal. So now we're ready, and let's take the derivative of both sides. So dy dx over here and d dx over here. And when we do that, the derivative of the natural log of y is going to be 1 over y, okay, times dy dx. Don't forget to implicit differentiation rules. Don't forget your implicit differentiation rules. And on the other side, you're going to have chain rule. You're going to have the chain rule right here for this guy. Here's your u. And you're going to have the chain rule right here for this guy right here. Here's your v. Okay? And so when you chain that guy out, the derivative of the first, which is 1, times the second, which is the natural log of x, plus the first times the derivative of the second, which is 1 over x. And so now what you're going to want to do is get that all cleaned up and get your dy dx all by itself. So how do you do that? Well, multiply both sides by y. And when you do that, you have dy dx equals the natural log of x plus 1 times y. And if you want to distribute the y, that's fine. And if you don't want to distribute the y, that's fine. But ultimately what you end up with, don't forget what y equals. Okay? Y equals this guy right here. So when you get done at the end, if you've got a y in your problem, and we do, then we're going to just replace that with x to the x. So my final answer, again, is going to look really interesting. But dy dx is equal to the natural log of x plus 1 times x to the x power.